Not really. It seems fairly simple, mostly just like a build on what was last time. So,
Right. Okay. And were you able to do the worksheet?
yeah.
Okay, perfect. So I guess we will just start. Thanks so much for meeting with me.
Oh, yeah.
Okay, so hopefully we can get through this pretty quick. So one, true, true. All right, so do you want to read question number 3?
All right. So, we're using the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 in the sample, 42 can taste it. So let P1 be the proportion of the population who can taste PTC, and P2 be the proportion of males in the population who can taste PTC. The research question for this study is given here. Is the proportion for females who can taste PTC different from the proportion of males who can taste it?
Okay, so I'm putting in the numbers right now.
Alright, pull up my calculator and do it.
So for the first one, so females being the first, so I got 0.743.
Mm-hmm.
And for the second one, I got 0.712.
Hang on. 0.712, yeah.
Is that what you got?
Mm-hmm.
Okay. All right. And then which set of hypotheses is appropriate for addressing the research question? So were they asking the research course for the study is the proportion of females who can taste different from the okay, so it'd be different. So it'd be P1 equals P2.
Is it with the hat? It is with the hat, right?
Right.
So there's only one option.
I'm almost positive it's with the hat. Hold on, let me just double check real fast. No, it's not with the hat.
Okay, then it's the other option.
Wait, I saw the one at the bottom. Let me just double check real fast.
Mhm.
Okay, yep, so it's no P hat. So it would be the last one.
Yep.
So 95 confidence intervals would be, let's see. So negative 0.123 and 0.185.
Right.
Let me put in the applet. You know about the Excel sheet that we're allowed to use, right?
No, I didn't.
You don't know about that?
I didn't pull it up at least.
Okay, because that's how I'm getting my answers so fast, is I have the Excel sheet.
Okay.
So all you have to do is just type in that information and then it gives you all the outcomes. And we're told that you can use it on the test and stuff.
Awesome. That is
Yeah.
very good.
So what did you get for the p-value?
Um, it's to plug it into the applet, right? I hadn't done that.
Yeah.
I was looking for that Excel sheet. Normal. I don't know the applet. So we would probably put in again. I'm sorry. This is. I'm all of a sudden I don't remember what to put in.
Oh, so it's 0.394. And you do both sides because it's a double tail,
Yeah.
a two tail.
So 0.694.
Yeah. So I did fail to reject HO, the null.
Yeah.
Or no. It would reject HO.
Reject.
Oh, no. It would be fail to reject. That's right, because you don't reject the null.
Yeah.
Okay, sorry. I sometimes get the wording confused.
You're good.
Alrighty. Okay, so which of the following statements best describes the outcome of this study? I would say that there is insufficient evidence to suggest that the true proportion of females who can taste PTC is less than the true proportion of males who can taste PTC. There's insufficient evidence to suggest that the true proportion of females who can taste is different, so it'd be B.
Yeah. That's what I was thinking.
Okay.
Alright, so questions 9 through 17 is the mortality rates and day of admission heart attacks with different data. So out of the 1,018 or 118,519 who had a heart attack during a weekday, 16,713 had died. And out of the 42,447 that had a heart attack on the weekend, 6,155 had died. So let P be the proportion of patients who had a heart attack and were admitted on a weekday who died, and let P2 be the proportion of patients who had a heart attack and were admitted on a weekend who died. The research question for this study is given here. Is the proportion of patients who have a heart attack and were admitted to the hospital on a weekday who die less than the proportion of patients who had a heart attack and were admitted to the hospital on the weekend who die? And the significance is 0.05.
Okay.
So are the conditions for conducting a hypothesis test satisfied?
Okay, so let me just read through it real quick one more time just to. Okay, so the conditions for conducting a hypothesis test are satisfied. I would say, let me check. Yep.
I would say it's true.
Yeah.
We have a good significance level. We have a p value, a p1 and p2 value, and the research question is sound.
hmm
So yeah, I would say true.
Okay. And they just asked for on a weekday who die less than the proportion. So it would be P1 is less than P2, right?
Because it's weekday is p1, yes.
Okay. Find P hat 1 around 2 decimals. So it would be 0.141.
Yeah, 0.14.
And then don't you put a 1 at the end?
Oh yeah, it is 3 decimals. Okay. Just checking you.
Yeah.
You're doing great, by the way.
Thanks, Ellie. And then the z-score, negative. What did you get for the z-score?
For the P2,
Yeah.
I got 145, sorry.
Okay. And then what did you get for the z-score?
So I need to look at that Excel sheet, but I would have to do it all by hand.
Okay. So I got negative 2.020.
Negative 2.020.
Mm-hmm. Yep,
Alright.
negative 2.020.
Okay.
What is the p-value for this test? And then for 14, because it's a negative, you would click on the left of
Yeah.
the applet, right?
Yeah, that's what I would say. So 0.0217. So 0.022 for P.
Yeah.
And so our decision, because it is significance level of 0.05, we would fail to reject the null.
Yep. No, so if it's 0.05, we would reject the null because it's 0.022.
But it's less than, isn't it? We just have a higher significance, like decimal wise.
I thought no matter what, like if the p-value is less than the 0.05, then it would always be reject the null.
Is that what it is? I get those switched all the time.
But I remember you chose another thing and you got it right another time. So you do whatever you want.
Yeah, we'll do. You just say reject, I'll say fail, and we'll submit it. We'll see what happens.
Okay. And then there's sufficient evidence to conclude that the proportion. So for mine, I would do A because they say there's sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital on a weekend who die.
Yeah, I'll do it as well. All right, let's submit it. You were right.
On reject the null hypothesis.
Uh-huh. Yep.
Oh,
I
I'm
missed.
sorry.
Oh well. Hey, it's not your fault. I was the one that was like, oh, it's this one.
No. Oh man. Well, you should look up this Excel worksheet because it's really nice.
Yeah, I just pulled it up and it looks great.
Yeah, because that way you don't have to do anything by hand. You just put in the information, and then at the very top, it'll tell you whether or not it meets the requirements because you can just look at the first and second samples, and it'll tell you if it's over 10 or not.
Wow.
And then you go down, and it'll tell you like the z-score, which is the test statistic, and then never use the p-value on it. Always, to find the p-value, always put the z-score in the applet.
Okay.
Because I've done it a couple times where I've used the p-value and it was wrong. So just take the z-score and put it in the applet. And then it also gives you the confidence interval. So it's really nice.
Yeah, this is great. I will definitely look at it a little bit more.
Yeah. So anyways, I know it's getting late, but thank you so much for doing this with me tonight.
No problem. Yeah, it was good. We got through it really fast. So
yeah, and I hope everything with Brooke is okay.
Yeah, me too.
It's sad. Okay, well, I guess I'll see you on Thursday at 6.
Yeah. So can we do it like at 5:30 and just do it quickly?
Yeah. Like we did tonight. Just go through it quick.
Yeah, I have a thing I need to get to.
Okay,
So,
no worries. Yeah. Okay,
that'll
so
be great.
5:30 we'll plan on that, and then could you just let Brooke know?
Yeah, I'll just send her a message on that chat. So
Okay. Thank you so much.
yeah, thank you. And
Okay.
we'll see you.
Yeah, see ya. Bye.